folks that we've assembled here, if there's a question that you can ask that can stump them, then I will give you $100 of Troy's money. So be aware of that. But I don't think you can, to be quite honest. But I know that one of them is obviously partial to cross the water there. We'll have Scott Franklin. We'll still let you be on the panel even though you violated the rules with your cell phone. But in any event, I want to turn it over to Troy. Troy's going to take you through the first part of this, and he's going to introduce our first panelist for us.
Great. Thanks, David. So Troy Winslow, I'm the Director of Auto Liability and Property Claims at TASB. So like Janita and David said, we're going to have this be focused as a panel discussion because I won't speak for David, but if you left it to me to talk about property and roof issues, we would be done by about now. So we're going to rely on our esteemed panel to help us out through the day. So let me get us started. So we've got three folks that are going to join me up here first. Let me ask Helene Hardy-Pierce. She's the Vice President of Technical Services, Codes, and Industry Relations with GAF. So Helene, please come up and join me. Thank you. Okay. Okay, next, Jim Flipowitz. He is the co-CEO of Calvary Construction. So Jim, please come and join me. Thank you, Jim. And Scott Franklin, he is a consultant with 4T Partnerships. Scott, please come and join me. So our goal with the panel today was to have representatives from various interests. So we've got Scott who does building consulting, Helene with a manufacturer, and Jim who does construction. So throughout the day you'll see a couple other folks that will join us later that represent some different interests as well. Okay, so what we're going to talk about first is basically the difference between low sloped and steep sloped roofs and discuss some pros and cons of various roof types. Okay, so I'm going to ask Jim, could you kind of just start us off and talk a little bit about just generally what's the difference between low slope roof and steep slope roofs?
Okay, get this. Does this come out of here?
There you go.
Okay, so a low slope roof is a roof system that is less than a 312 pitch. A steep slope roof is one that, of course, is greater. So most homes, residential homes, where you have an A type of a roof, that is what we call a steep slope. Flat roofs is another term for low slope roofing. I think on most of your, those are more prevalent on commercial type of buildings.
Okay. Let's jump in then, Jim. If you could continue to kind of go through with us, what are the most common types of low slope roofs that are out there?
Okay, the major ones that we run into in our work start with a asphalt roof or built-up asphalt roof system. These consist of layers of ply felt, usually fiberglass reinforced ply felt, alternated between layers of like a liquefied asphalt. That asphalt can be applied either hot, it can be applied cold. Generally on a built-up roof, the top layer or the layer that you're going to see is either going to be gravel, a gravel ballast, pea-sized gravel, generally pea-sized gravel, or a modified bitumen or something in that modified bitumen family. The next one, sprayed polyurethane foam, SPF roofs. This is where they apply basically a polyurethane foam is sprayed to the roof, and that provides you with some insulation values and of course waterproofing values. The sprayed foam roofs are then either top coated with an elastomeric or a suspended solid silicone spray. That's really where you get the longevity out of a system like that. Thermoset membranes, TPO, PVC, these are kind of I think these are my favorite to install. Certainly, I think this is the preference that we see with a lot of architects. They have a lot of really good qualities. And on the TPOs especially, we're into, Helene can answer this better than I can, 5th generation or so.
Over 20 years.
So yeah, 20 years they've been in, and every generation, the technology gets better, they become more reliable. Honestly, this is probably, again, this is a good roof choice. Spray or roll applied liquid systems. These are coatings. In the day, elastomeric type of a coating that's almost like a paint was the choice. The new generation on spray foam, or I'm sorry, on sprayed roof coatings are the they're solid suspended silicone. When they are applied, they almost have a rubbery type feel. As most coatings, the more coats you put on, the better the performance. Metal roofing, you see that a lot. They are, but you don't see them on a lot of, low slope applications. You've got APP systems and the SBS systems. That's like the newer. And again, I'll let Helene explain to you the technology behind the SBS systems. So,
Yeah, and I think there's a topic where we'll get to that, where we talk kind of
Yes.
specifically about that. So,
Yes.
Okay, good. I'm going to pass it over. I'm going to jump through some of these and ask Scott to talk about steep slope. So David, could you hand the microphone over to Scott? Is it?
How's that?
There you go.
On the steep slope, we've got a number of different products. You've got the tile and slate products, which are more your clay, prefabricated products. We've also got asphalt shingles that will come in multiple different categories and designs or appearance or aesthetic looks. You've got a 3-tab shingle, which is probably on the lower end, typically a 25-year warranted product. The other thing to remember with a lot of the steep slope products, where we're talking about greater than 3-on-12, is they are water shedding products. They're not typically waterproofing products, whereas waterproofing falls into that commercial low slope, 3-on-12 and below. Although we do have some membranes that have now been tested upwards of 5-on-12 that we can still get a Class A and still produce a waterproofing assembly rather than a water shedding assembly, like what we have with typical steep slope products. We have the 3-tab, then we have the laminates. Laminates came out, I'm going to say 1980s, roughly early or late 70s. Those products are a 2-part product that are then put together at the plant using sealant. They have a glass reinforcement. Going back into the 60s, most of your shingle products were manufactured with organics, so they were a bit heavier. When we made the transition over to glass reinforcement on shingles, that allowed us to put more weathering grade asphalt into the product, although they were a little bit lighter. Most of your shingle products can be attached with either 4 fasteners or 6 fasteners. Most that we recommend will go 6, typically nailed or barb nailed when they're secured. Each one, interestingly enough, on the shingle side, from an identification standpoint, most manufacturers have their own sealant pattern, which allows them to be able in the field to identify whose product's whose. But those sealant tabs will then seal to help resist with the attachment. The last category we have are the Class 4 shingle products. You have two categories in the Class 4, at least the way we look at it. One is using styrene, butadiene, styrene, or SBS asphalt modifier. They do that to make it a softer product. By having a softer product, it has a little bit more self-healing characteristics when exposed to hail, has a little bit more absorption of the punch, whereas you also have some Class 4 products that have tested out where they've gone to an enhanced reinforcement using glass reinforcing, which satisfy the requirements under Class 4 and testing through UL as it relates to the products. We talked about the clay and concrete systems. You do have to be careful. You get into the 20-year or older clay products, you can sometimes get into some asbestos issues. So it's always something to look at when you're getting into some of the older products. We have the tile and the slate, and then you have wood shingles and shakes. Those have become far less frequent today. Part of it is due to the fact that they can be less resistant to hail. They can also be a little bit costly to fix. And with the new fire codes and a lot of the codes that have been adopted around with the cities, the product that you need to get in the shake product category to meet the fire ratings is pretty costly. And then there are some outlying derivative products, custom aesthetic products, but that covers most of them.
Okay, good. Anything about any of these slides, Scott, that stand out?
You can back up to that first one. Okay. The first one there is showing what appears to be some wind damage. One of the things that we'll look for is that sealant pattern, A, to see whose it is, B, to see if the fastener has been placed in the right location. That's critical because if the fastener gets placed in that sealant pattern, that can inhibit the ability of the overlying shingle to bond with it, which is where it's going to get some of that resistance. Your 3 tabs generally have been tested out to have the lowest wind uplift or wind resistance of the categories. Laminates by far have better, and Class 4 is going to be in the same category as the laminate shingles.
Okay. Okay. I'm going to jump to metal, Scott, and keep you kind of on the hot seat. So can you talk to us just about metal roofs in general? Let's say the different, the different gauges, potentially the cost and application and such.
When you get into the metal roof systems, we've got a number, and it seems like it grows every year. You have some of what we're looking at here is more of the R panel, metal building type structure. Some of the metal building manufacturers have gotten very creative to where they've gone to hard exterior claddings so they don't look like metal buildings. On the other side of the spectrum, we have some pretty sophisticated standing seam assemblies. Some of those are in the categories of snap lock or batten lock. When you get into the actual seaming of the system, that can become very unique with each manufacturer. Some of these systems actually get seamed with a machine that runs across that feeds butyl tape into that seam so that we're assured we have a full, complete seaming of that product, both from a wind uplift standpoint as well as a weather tightness standpoint. So that can be critical. A lot of your R panel products you're going to see are more exposed fastener, whereas your batten lock, your snap locks, your mechanical seaming products are going to be free of any visible fasteners. They utilize fasteners and clips as the system goes down to achieve their factory mutual uplift, I-60, I-90, FM120s. And they do offer a little bit better weatherproofing. When you get into your batten lock, your mechanical seams where you don't have any visible fasteners, those are the assemblies that we typically see where the manufacturers are going to give us what's called a weather tightness warranty, whereas some of the other ones that have exposed fasteners don't have a weather tightness warranty. You'll also find on most of the weather tightness warranty guarantees, they're going to require that we go back with an underlayment that utilizes peel and stick, usually a 40, 50, 60 mil bitch-a-thing product, very soft asphalt, usually fog on a wood deck, put it down so it's got a little bit of a bite to the deck, but it gives us some of those waterproofing characteristics rather than just relying on water shedding characteristics. You'll also see in this particular picture where it has striations. Most manufacturers have now gone to the requirement of utilizing striations in the panel. Those are there because they help us reduce the amount of what's called oil canning or rolling that you will see after the roof product's been put on. They do allow you to purchase this product without striations, but typically are going to ask you for a waiver if you're going to take it because they don't want to have any issues as it relates to any oil canning after the fact.
Okay, I'm going to close out on the metal roofs and ask Jim if you could just comment a little bit about what the market is like for metal. Is there any cost fluctuations that are occurring currently?
Absolutely. I mean, metal is a volatile priced product. So generally, I know on our bids, our metal bids are good for generally 30 days. The market for this is so-so. I think we put on more asphaltic or single-ply membrane products than we do metal products. And a metal roof can run anywhere from $400 a square for a not very good R-panel roof to north of $1,000 for some type of a sophisticated proprietary system.
Especially if you get into curved, where you've got a barrel type assembly like this. Those are very difficult to install. They're fairly labor intensive. They have to be pretty exact with their panels. Most of those panels either have to be fabricated on site or shipped to site, so you can imagine what these panels are like to get out there on a job site. And we've also had a lot of fluctuation recently with some of the trade between different countries.
Yes.
It has dramatically shot it up. We've seen as much as about a 26% increase since last year, 12 to 14 months ago, in an effort for this administration to kind of reduce some of the outside the country suppliers that were bringing metal into this market.
Okay, good. So I'm going to jump back and ask Helene to talk to us about. Let's go to this slide over here. There we go. Could you talk to us about, let's say, just the general differences between TPO and PVC roofs?
Okay, so let's first get on the same page. These are a category of they're the thermoplastic membranes. And when we think of single ply, we have thermoset and thermoplastic. Thermoset is your EPDM. It's been around since the 1960s. Thermoplastics, TPO and PVC. PVC was actually introduced in the 1960s and really gained a footing in the 1970s. And what a thermoplastic material is it's kind of like a stick of butter, right? When you heat it up, it melts, and when it gets cold, it becomes a solid. And so with any thermoplastic membrane, either TPO or PVC, it allows you to heat weld the seams. So you're not relying upon a glue or a tape to keep water out. So that's first the general category. PVC's been around for a very long time. There are some misconceptions about it. Back in the 1980s, there were problems with some products that were introduced that were not properly reinforced. And so there was people say, oh, that's the stuff that shatters. Well, that's a misperception. And that's 30-year-old or 40-year-old. Now we're beginning to show our age because we remember some of that. But those membranes, they do perform. They're typically very flexible. When they're heat welded, you'll see a bleed out at the lap as opposed to TPO. TPO is a little bit more rigid. PVC offers two benefits more strongly than TPO. One is fire resistance on slope. So a lot of times you'll see these, I think of them as striking buildings that an architect maybe shouldn't be thinking that we can do something that'll keep water out of. But, these big, hyper-parabolic type of roof structures that go well over a 1 or a 2 in 12 slope. And PVC has got inherent fire resistance. So that is the single-ply membrane that'll give you fire classifications typically on unlimited slope. The other benefit is if you have animal fats or grease. PVC, of all the single-ply membranes, is the most resistant to that type of contamination. So when we think of restaurants or we think of areas where there may be jet fuel is another one. So sometimes when you see a white roof in airports, you're probably looking at PVC because it is more resistant to, like I said, animal fats, grease, and jet fuel. So that would be, but in terms of, and you look at this fire resistance, we're going to get into hail resistance, I think, pretty significantly later. But when you look at the thermoplastic products as a whole, right now across the United States, they're representing over 60% of the low slope roofing market. TPO has the lion's share of that. The PVC has been a very steadfast and significant piece of it with, you know, just a consistent market share, and it's been gaining a little bit every year.
I would tail off of her comments with the fact that that particular family category has also offered some significant risk reduction to contractors from a safety standpoint versus working with, you know, 400 or 500 degree asphalt in the field. It's also got some benefits as it relates to bigger windows of success, both from the size of the membrane you can work with. And it also has offered some characteristics where a contractor might be able to go in, completely do a new roof without interrupting what's going on internally with the operation of that building, whatever the building use might be.
Certainly that, and if we're going to talk about kind of features and benefits, this product category of thermoplastics, you have the whole cool roofing. They're white, generally white, although you can also get them in colors that also will have high reflective values like tan and grays. So you have that. You have, and I don't know if we want to get into attachment methods, but across, so across the single ply, or really the roofing industry, it used to be that you used hot asphalt, and that was considered adhered. And then with single plies, you used glue, that was adhered, or you could mechanically attach or ballast. Today, we have a huge, it's become a much larger field. So in the fully adhered, we have, not only do we have traditional solvent-based adhesives, but we now have water-based adhesives, which, thank goodness, down here in Texas, you don't have the problems they have up in the Northeast or up in northern climates where they have temperature window problems. The water-based also will address VOC concerns, right? Volatile organic, you know, the stuff, if you can smell it, it may have a VOC issue. There also are low-rise foams that are now being used, and I have a sample here if somebody wants to pass it around. With a fleece back type membrane, it can go down in low-rise foams.
Pretty cost effectively.
And pretty cost effectively, and when we talk about hail resistance, that's really important, all of this adhered talk that we're talking about. Then you get into mechanically attached. Mechanically attached was traditionally right down the lap, 6 inches or 12 inches on center. PVC membranes were 6 or 8 feet. They're now as wide as 10. There may be a 12-foot wide sheet. TPO is generally 10 or 12 feet wide. But now we've gotten into this kind of hybrid called a Rhinobond system. It's a trademark of OMG that actually uses induction welding to a plate. And it kind of combines the best of, when you think of wind resistance, fully adhered provides much better wind resistant. It provides better, not much, because you can get high ratings with mechanically attached, but when you go to Rhinobond, you're distributing the load on the membrane much more uniformly and also on the substructure, okay, on the deck, as opposed to running it in 10-foot long, you know, across the deck. You're distributing that load, and you can get high.
Very careful. You've got a limited. I was just going to mention you have a very limited number of products you can use with the induction.
It's
because of how it gets bonded.
right. It's thermoplastic. It's PVC and TPO. And then ballasted is still around, but because of wind concerns, you're not going to see it in the 14-county coastal area of Texas. But there are ballasted systems where you really want to protect the membrane, or you're going to use the roof for something else. And so we also talk about the roof as another surface. So when people think about garden roofs, or they think about using the roof as a working surface, a ballasted with a paver type system. So there are a lot of different options on attachment, but generally when we think of like schools or commercial type buildings, it's generally mechanically attached or fully adhered. So
Okay, good. Let me do a time. Turvin, how are we doing on time? Good, okay. So Helene brought a sample, and Jim brought some samples as well. So we hear that there are maybe differences with these types of membranes as far as thickness and what's underneath. So could maybe you all speak to kind of what's available and why that matters?
okay, I'll start from the beginning. The beginning would be thin. Single-ply membranes, they are a highly engineered, quality is built in the manufacturing plant, but they are single-ply by nature. And so they come in range in thicknesses from 40 mils or less, slightly below 40 mils on the PVC side, up to 80 mils plus fleece.
And what is mil? What does that
Mils
stand
is
for?
thousandths of an inch. So 40 mils is 40 thousandths of an inch. At each table, I think, are two different samples. One is 60 and one is 80. If you take the 80 mil, or here is a 40 mil sample, okay? But you take the 80 mil and consider that it would be half as thick if it was 40 mils thick. I generally consider in TPO or PVC, so in PVC you're talking 40 mils, TPO 45. Those are really a utility standard sheet. A utility sheet, yes.
Just to verify, this is the 40 mil sample, correct? Just to verify?
No, here, I
I
have
think
the
it's
40
right
mil
here.
here.
Right
That
here.
may be
Right.
50. That may be 50.
Right.
Okay.
So some of the samples are not labeled, but just to
Oh,
clarify.
no, those are just at our table. Whoops, sorry. Oops, I'm sorry. There, the one
Thanks.
being passed around is 40 mils, okay?
I think we just had one of the
One 40 mil.
mils.
There's one 40 mil, you can feel it. So, but the utility grade is generally 40 to 45 mils. What's important in the thickness of the products, and I'll compliment the ASTM group working on the TPO standards, is it's not just the thickness. It's how much the weathering layer is above the reinforcement. And in the TPO standard, over the last about 5 years, they've actually worked to increase it to make sure that even as you increase in thickness from 45 to 60 or 45 to 80 mils, that you are likewise increasing the amount of weathering surface so that we can't cheat as a manufacturer and just put a whole bunch of stuff on the bottom that doesn't cost a lot. So it's really the amount in what we call the cap, which is the thickness above scrim. And so the TPO standard actually requires as you go up in thickness, you also are increasing the amount of actual weathering. And to give you just a general rule of thumb, we have a lot of hot areas in Texas. In Phoenix, Arizona, you will be hard pressed to find a roofing contractor who will install 45 mil. They just know that in that high UV loading, heat loading, that you start with 60. That's their base. And if you think about what wears out a thermoplastic membrane, it's exposure to UV and temperature. Okay, I mean, and all types of other things, but it's UV and temperature in terms of what attacks that weathering surface. So the more weathering surface you have, the longer that product will perform. Now, 45 mils, I've been up on roofs in Las Vegas, which has very, very high UV and heat loading. And let me tell you, when we were up there, it was hot. That on roofs that are 15 years old, that were 45 mils.
So when you
But
say
it's
the weather,
chalking, and you can begin to see, when it's aging, you'll begin to see the reinforcement. You'll see chalking. You know, you run your fingers across it, they'll come up white. And that's just the weathering of it. But I've seen 15 mil go 45 years in a very high heat loaded.
You can also see that, what you're talking about, the chalking, where you start to see reflective surfaces, where the sun will hit, say, glass, down on a walkway or lower surface, and it will accentuate the amount of UV that's hitting that and just pulling those plasticizers right out of the sheet.
That's a really, really key. A lot of people say, how do you look at a roof and tell when will it probably need to be replaced? And it's just a trick. You go to wherever you've got something like a curb, right, an air conditioning curb that's facing south or west, that's got if it's a white membrane. And then you look at the membrane about 3 feet out from there. So it's been being reflected. So it's been getting double the heat load. And if the membrane there is in good shape, you're good. But if you begin to see chalking there, then you know you're getting towards the end, whatever, I mean, maybe 2 or 3 or 4 years down the road, but that's where you're going to see weathering first.
Now, I also think, and correct me if I'm wrong, but the NRCA has also come out now and pretty much established 60 mil on the TPO side as, hey, pretty much that's the standard for the industry. Although they have others, that's really where they want owners to look at from a baseline.
Like I said, you know, you look at Arizona where they won't, when you look at the thickness of the membrane is going to predict how long it'll last. And so if you're investing in a roofing system, to invest a little bit more upfront for a thicker membrane just makes sense. From an economic standpoint, there still are a lot of large buildings that are installed that they'll install 45 mil on. It also has to do with building location. When you go up, you know, outside of the Sun Belt, there's an awful lot of 45 mil that is still sold in the United States. But 60 is really the lion's share.
And there's some enhancements that also some of the manufacturers offer for membranes that were specifically made to reduce heat load out there as options. If that's your big concern, you're going to get a lot of reflective off glass or something. Some of the manufacturers actually make very specific product that are going to weather and perform better in those types of scenarios.
So you mentioned a couple things about kind of the weathering surface and maybe indicating that might vary, even if it's a 60 mil, that the weathering surface might be kind of different. And then you also mentioned a term called scrim. Could you kind of speak to kind of both of those, or maybe in a little bit more detail?
Okay, so thermoplastic membranes really have 3 components. There's and they're an extruded. They're an extruded thermoplastic polyolefin is TPO, and extruded PVC for PVC. The bottom is what we call the core, and the core is typically, you know, TPO or PVC, but it will have fillers in it. It typically is gray or dark gray, and then the scrim is the reinforcement. I talked, you know, long ago there were problems with unreinforced membranes. We still use unreinforced membranes in flashings, but it's reinforcement, and the reinforcement provides things like fastener pull-through resistance for wind resistance on a mechanically attached system. It also provides stability to the sheet itself. And then you have the cap, which is the weathering layer. The cap will have both, in TPO, it'll have your fire-resistant package. It'll also have UV stabilizers, which retard the aging of the membrane from ultraviolet exposure to ultraviolet. So that's the 3 components of the product. We talk about the cap and we measure it as the amount of material over the scrim. And generally, it's going to be 50% or more of the total thickness should be, you know, or not exactly because you have to measure the scrim. But for example, you know, we talk about 19 mils, you know, a minimum thickness. And the ASTM standards for both PVC and TPO have requirements within the standard for the amount of weathering surface over the scrim, so that it can't be very, very thin. Because the thinner it is, obviously, the faster it's going to weather. Scott talked about there are some formulations that are specifically formulated for high heat installations. Heat degrades polymers, and it's, I'm not a chemist, I didn't like chemistry, but there is a theorem that talks about for every 10-degree rise in temperature, you know, there's an exponential increase in the degradation of material. And so these high heat-resistant sheets are specially formulated for either where you have extreme UV exposure or where you know you're going to be like a steel mill that may have very, very high, you know, what you may be doing something special inside. Another thing that, while it's gone, we've stepped back away from it. If it comes back, are thin film PVs, thin film photovoltaic panels. When those were originally glued to thermoplastic white membranes, everybody thought, well, this is great. We have a white membrane, it's reflective, and we're going to be generating electricity on the roof. And there are a few of us that we raised our hand. And because the thin film people came to manufacturers and said, this isn't going to have any problems with your, the glue is going to be fine with your membrane. And I raised my hand and said, well, wait a minute, but those thin films are dark. And we're talking about a white membrane that we expected, even when it has dirt pickup, that the rooftop temperature is going to be around 130 or 140 degrees. And we know from black membranes, they reach 170 to 190 degrees. And so we raised our hand and said, isn't that potentially a problem? Are we going to prematurely heat age white membranes? And, oh, don't worry about it. Well, no, wait. So we actually measured. And what we found is on those thin film solar panels, the temperature even between panels was reaching 180, 185 degrees. And surprise, surprise, those panels that were installed on white thermoplastic membranes actually caused premature cracking and failure of the membranes that they were installed over. Because of that, there were these high temperature resistant TPO in particular membranes that have been developed for those types of installations.
We saw a similar effect when we saw some of the industry folks start going to dark or black walk pads and throwing these all over the roof because they wanted that contrast to show everybody exactly where to walk. What we've seen historically is wherever we put those is exactly where no one will walk, except for putting them next to the service-sided units where they'll most commonly set their tools or equipment at. But we see some of the same effects, which is why one of the things we try and do when we incorporate and build a spec to work with a contractor or general contractor, who we're working with, is try and minimize some of those darker components on that roof to limit some of that and to limit some of the reflectivity off of some of these units, because some of the same effects occur that you're trying to gain the benefit of that energy performance of the envelope, so don't take away from it by putting all this dark stuff up.
Okay. Let me ask you one last question real quick, Helene, before I jump to Jim. Cost difference between the various mills, is there a general kind of striation of what the cost difference is as you get thicker? What drives that?
It's a material cost.
Okay.
And so, and when you look at some of the high temperature loaded products, that also because it has more high cost UV stabilizers. But when you think about the cost of a roof, if the cost of a roof is $700 or $800 per square, or $7 or $8 per square, when you start talking about a 20 cents, $7 or $8 per square foot, when you start talking about a 10-cent increase per square foot in the price of the membrane, that's not a very big increase, or 20 cents in the overall cost of the project. And Jim is probably better to address this than I. So.
Exactly. I think it pays to upgrade your membrane because it costs just as much for us to install a cheap 40 mil membrane as it does for us to install a 60 mil membrane. Your labor cost is not going to change. So really, when you pay for an upgraded roof, you're paying for the material upgrade only.
Okay.
We've run across, and this isn't going to be all the cases because you have so many different types of assemblies with different numbers of penetrations and those kinds of things. But when you start to break these things down, you could literally draw a comparison and have someone price up assembly A with a 50 mil or 40 mil and assembly B with a 60 or 80. And the difference in cost of the material equates to about the price of the warranty from the manufacturer. Yes. And you say, okay, do I really want to buy a piece of paper or take that warranty fee, put it into this system and have that system perform and be able to maintain it for a depreciable asset value of 20 years or more? It just doesn't make a lot of sense to buy a piece of paper when that's what we're really looking at here, cost difference, to go from a marginal product that likely is going to resist very significantly less than 2-inch hail. And when you look at the map we hit, how many times it's going to be exposed to those on an annual basis, geez, this sure doesn't make a lot of sense to trade a piece of paper for when I can beef that thing up.
Okay.
Just making sure that we take into account the boards that all of the membranes sit on.
It's a dramatic.
Yeah, just
you
talk
can-
about that a little bit.
You
too.
can dramatically affect that just in the type of overlay boards you may choose or insulation package. You have your insulation package first that goes directly over the deck, along with any cricketing, sloping type stuff. But then you get into the cover board where you get into a number of products. You've got gypsum type products like Densdeck and several others. You have some reinforced high heavy duty products that have come out lately, like the Invinciboard, 1/4 inch to 1/2 inch. Those can make a significant contributor to the performance of that roof membrane, both through giving it a substrate to put that membrane on, either mechanically attached or fully adhered, but also giving it an ability to repel any punches, foot traffic, hail, whole wide range of things that you're going to be moving across this roof. The density of what's underneath that membrane dramatically helps it or dramatically hurts it over the life of that roof. And
Yeah, no, we'll talk about it.
Yeah, okay, let me finish it off. So Jim, about a minute or so, can we switch gears a little bit and speak to built-up systems specifically? Are you seeing them much out in the market? Are you, when you're doing replacements, are folks, how popular are they?
Not very. We remove a lot of them, but we're not replacing a lot of them. Both Helene and Scott alluded to this earlier, but the installation from just an ease of installation, from the speed of installation, safety, equipment. You're not using a hot torch on the roof. You're not using a kettle with hot tar. You don't have the fumes that are associated with hot tar applications. I think I can tell you this type of system, any type of a built-up system, are probably no more than 15% of our roof replacement business right now.
Actually, you're spot on. Nationwide, asphaltic systems are about 18% of low-slope roofing systems. It's not because they don't work. It really has become an economic, a lot of it is labor-driven. The roofing contractors, labor is their number one concern, and these typically are labor-intensive. But from a performance standpoint, they perform very well. And when you talk about tearing off, you're tearing off 25, 30, 35-year-old roofing systems that kept water out for a very long time.
along that, and I just want to throw this in because we're talking to both school owners, public facility buildings. You look at the compatibility of the asphalt system today to the environment in which a school operates or a facility where the public comes in and out of every day, the fact that those buildings have to be accessible throughout the year, and all of a sudden that, along with fire code and other issues, really start to limit a contractor's ability to successfully go in, get that roof system put in and in place safely for both his people as well as the people that are in or trafficking through that building. It doesn't take one drop of 500-degree asphalt coming through a plumbing stack and into a building to hit somebody before everything shuts down pretty quick. And then tack on to the fact it's become so costly to maintain the equipment to where you can effectively put the right amount of material in site. The cost of having someone maintain a kettle so that it complies with fire codes, complies and doesn't cause mass evacuations due to smell. All of these factors, both risk to the contractor, risk to the public, and you start to look at other systems that have now gained some history of performance, and it gets pretty cost effective.
Yeah,
Okay.
I agree. It's difficult to even find a crew that even has a kettle anymore. Most of them, have gone away.
Okay, great, guys. We got the time sign, unless, Kim, there's a question?
He's got a question here.
Okay.
Real quick.
Sorry, and I don't know if this needs to wait to roof planning and purchasing or roof planning and buying. I was recently speaking with my roofing consultant, and he wanted me to be aware that TASB was eventually going to be sending me a letter stating that they would no longer, that they would cover, but up to $1 million on 3 or 4 certain types of roofing types. Is it? Can anybody speak to that? Is that true, or was he saying something that?
We can speak to that probably offline. So we'll catch you at the break.
Okay.
Which will be now.
Troy,
Okay.
let me very quickly, let me quickly address that, and then Troy can give the fuller answer to our school district attendees. It is in fact true that we are sublimiting roofs that have single ply roofing systems that don't meet hail resistance standards. That is driven by lots of data and research on losses over the years. We would love for you not to be putting those roofs on. We had a meeting with a roof manufacturer, a large, very well-known roof manufacturer, and we were prepared to say, this is a terrible roof, why do you sell it? And they said, well, this roofing was never intended for this climate. And we said, well, then why do you sell it? And they said, because that's what they spec out. So in fact, part of our purpose today is to sort of get that message out that it is not that much more expensive to upgrade. In fact, we're working with our members when you have a loss to work with you in sharing the cost of upgrading cost. But that's what is driving that decision. You can't afford the premiums it would cost for us to continue replacing those single-ply roofs as often as we do.
Okay.
But Troy will give you all the details of that. Or Mary Barrett can also speak to it.
Okay, with that, let's take we got 10 minutes, and then we'll come back and continue the conversation.